Alright, so let's look at the physics of this type of lens, the double convex. So we're going to send some light through, just like we did with the mirrors. We're going to send it in parallel to kind of the base, to the surface. Now the difference between a lens and a mirror, this is glass here, right? So what's the light going to do? Instead of reflecting in a mirror, it's going to refract. So the direction it refracts, well, maybe you guys can remember, it's a good review problem. If this is 1, n equals 1, and this is like 1.5, and this is 1, is it going to bend towards that normal or away from the normal? Towards the normal. So it's bending towards the normal here. Okay? And then on this side, our normal is going to change a little bit. So now we're going from 1.5 to 1. So it's going to bend towards or away from the normal? Away. So it's going to bend down again. And if you look at this, the top of this almost looks like a prism, right? It's kind of a curved shaped prism. So, and that was the same thing a prism would do. What if I come from the bottom? What should happen? Okay, it's just going to bend in the different direction, right? So let me do a few of these. 1, 2. What if you send it straight through the middle? So it hits right on the normal? Should just keep going. Oops. Anyway, what do you notice about these beams of light? What are they going to do? They're going to all focus on a single point. Okay, so that is what we will refer to as what? What do we call that? The focal point. Right? And you guys have probably all done something like this before with the magnifying glass. If you ever gone outside with the sun and burned stuff with your magnifying glass, right? You focus all that light on a point. And actually what that is, that's the image of the sun. That focus that you're doing, you're creating the image of the sun right on that point. Now what happens if you flip the lens around? Does it still work?
Yeah.
Yeah. So if you sent the light in from the opposite end, you would get the opposite effect. And you would get a focal point on the opposite end. And these would be the same distances. Okay, so f, whatever f is here, that would be the same f over here.
What was it they had their different radius of curvatures?
If they have different radius of curvatures, that would affect the focal point. However, it would still create the same focal point on both sides. So, you know, if this side was bent more and this side was bent less, even though it would change it from what it is right now, it would still be the same on both sides if you flip it. Okay, good question. So keep this visual in mind as we start drawing these out. This will help guide you in your drawings. Yeah?
What happens if two sources of light are coming in both sides?
It'll just go right through you. I mean, right through it. It'll just pass right on through. It's like if you take two flashlights and shine it through each other, it doesn't like stop, right? The two light doesn't stop, it just keeps passing right on through.